Good afternoon.
Good afternoon.
I just want to give you
Hello.
props, by the way, for being such an amazing teacher. Because
I'm
not
late,
all
I'm
teachers are
sorry.
the same, and you really care about your students. Just
That's not true.
Damn, I'm
I can tell.
That's not true. Who told you that? They're spreading dirty lies. Olivia, that is a cute kitty.
And
I'll
Linnea
see if-
Wilson told me.
Oh, cool.
No, I used to work with her, so.
Yeah,
He's a
Linnea's
little
awesome.
overweight.
So my gray cat, Mr. Mortimer, is actually having kind of a chill day. I might be able to show him to you guys. He's the cat that we've only had for a couple of months now, so I'm going to see if I can grab him. Mortimer.
Hi
He's a little
guys.
overweight, but she's super chill.
Can y'all hear me?
Yeah.
Liana.
Okay, cool. Just making sure you can hear me first. My brain. It has been staring at the screen
Oh,
too long.
cute.
Oh, look at the baby.
He's such a fraidy cat. That's Mr. Mortimer Biggs.
Aww.
He looks
Mr.
like
Mortimer.
Church from Pet Cemetery.
Oh, wow. But yeah.
He's scared of like noises, so even just what's coming out of the computer, he's like, that's gonna kill me. I gotta go.
Poor baby.
He's a lot better though. He used to spend like all of his time hiding in a little nook in a room, and now he's pretty much out all the time, which is great. So he's getting a lot more comfortable in the house.
I had a little black kitty that was like that. She
Okay, we got 2 jobs today. Job 1 is we are going to do a little bit of review for the exam that's coming up. Hopefully you guys saw the announcement that the exam is going to be open from Friday through Sunday. So you don't have to take it on Friday, which is great. You could have up to, until Sunday afternoon to study for it if you want. So hopefully that helps, since we do have some due dates this week.
What exam?
What exam?
Oh my
I
god,
can't even keep a
Catherine,
straight face,
don't
I'm sorry.
even. Don't even.
You
The
probably
exam
already
that's
like
coming
did
up
it.
this Friday.
Girl, I know you did the practice exam. Don't even trip.
Yeah. So
Probably already
anyway,
did the exam.
what I'm going to try and do for Tuesday, Wednesday, Thursday this week is spend maybe 15 minutes at the beginning of class doing a few problems like this. And then after that, we will spend the rest of our time looking at chapter 4 topics, because we do have to keep on going. Remember, chapter 4 is not covered on the first exam, but on our overall course schedule, we got to be looking at chapter 4 this week. So we'll spend a little time reviewing, and then we'll do chapter 4 stuff. That's the plan anyway.
We're gonna keep on trucking.
We gotta. The only other alternative would be like finish up chapter 3 last week and then have the exam on Friday last week. So I think it's much better to give people a little bit of extra time after we've talked through the material. For those that couldn't come to the recitations, they can watch them sometimes 2 or 3 times if they want to, and have some time to do some digestion,
Want to do anything fun for the full moon? I just realized I never asked anyone's religious preferences in here.
It was last night. It's no longer a full moon.
Yeah, that's why I asked if anyone did anything.
I slept like a baby for
That's
the first
nice.
time in weeks.
I'll text
Full
you.
moon.
Oh, last night was, it was a pink moon too.
It was a pink supermoon.
Cool.
It was pretty.
It was pretty.
Right now it's not chemistry, but it's, sciencey, right?
Okay, so today
That kind of reminds me.
7th.
I don't know why, but that kind of reminds me of some sciencey pottery stuff.
Okay.
Sciencey chemistry pottery stuff. There's some guy that made this ceramic stuff that is you can see through without any like there's no distortion.
There
Some
are
guy-
kinds of china that are transparent or close. So one of the ways you can tell fancy, it's called bone china because it's actually.
Oh my
made
God,
from
you hold it up
powder.
to the light.
It's really expensive, but sometimes like that's something that you can find sometimes at estate sales that people don't know what it is. And you can buy like, if you get an entire set of bone china, it could be worth $1,000 or a couple $1,000s easily. And you could sometimes get it for $50 at an antique sale. Yeah. So that's something to keep an eye out for. And that's how you can tell is it's normally like off-white colored. And if you hold it up to the light, it's very translucent. That's bone china. It's really pretty too.
My mom has some bone china. I think she's tried to put it through the dishwasher once.
I'm sorry, what?
Look at all of our eyes like,
I know.
oh, what?
Okay, I know I'm ghetto, but Jesus Christ.
That's not ghetto. That's just not understanding what you have or how to take care of it.
Yeah, it is pretty fragile stuff.
It is. It's like
In our house, we go the opposite way. We use Fiesta ware for almost everything because like if you drop that stuff, it's probably not going to break anyway. It's almost indestructible.
Yeah, Fiesta ware and what was the other one? Cambrian? I can't remember. Something with a C.
we should probably do our chemistry now.
I'm doing it. I'm talking and writing
Yeah,
at the
I'm
same
I'm
time.
seeing people working, but that is what we should be focused on. So these practice problems are for your benefit, same kinds of things that you might see on an exam.
By the way, I know I got this wrong on the practice exam.
Which
Because I
one?
went back through my notes, the addition one, because I
Did you
didn't.
use the multiplication and division rule? That's
Yeah, that's what I did. Like it was right, but my last answer was wrong. The final answer was wrong. All the work was right, but the final answer was wrong because I did the wrong decimals, not decimals, you know.
Oh, helpful. Okay.
That one. I already have a question. That's fun.
Ah,
Why is
it's so hard to stack two windows next to each other because Zoom keeps on thinking that I'm trying to do something with the meeting instead of just the windows that I'm looking at.
It's trying to be helpful when it's actually not at all helpful.
It's not helpful at all. Exactly. And all right, that's close enough. So if I just put in the first one of the calculations into my calculator, 1020 plus 4.18 plus 18.7655. There's what the calculator spits out, 1042.9455. That is definitely not the right answer. So how do we turn this into the correct answer with respect to significant figures?
Fuck, how do I raise my hand on this thing again?
You're the one who taught all of us.
Shut
Jules.
up!
Jules, how do I round this correctly with respect to significant figures?
So because there's you're gonna go to the thing, so with all of the digits there's only there's the least number of significant figures in one of them, and you
So you're
say-
saying that because 4.18 only has 3 significant figures, I should round the whole answer to 3 significant figures?
No, that's for multiplication and division. Hold on.
Exactly. That is the most common mistake that is made in this question. All right. And that's exactly why I put this on our list of questions so that you don't make that test or mistake on the test. So what's our rule for adding and subtracting?
Decimal places.
Decimal places. We have to round to the same, and really it's a little bit more complex than that. It's like we have to round to the same numerical place as whichever one has its last significant figure at that numerical place. But for the problems we're going to come into in this class, decimal place is fine. So out of all the measurements and their numbers of decimal places, we have to round to the same number of decimal places as whichever one has the least number of decimal places. So 1020 has no decimal places, 4.18 has 2 decimal places, and 18.7655 has 4 decimal places. So it looks like we've got around to no decimal places, just like 1020. So 1042.9455 would round to 1043 with no decimal places.
And that's because you purposely put the decimal after the 1020,
Yes,
right?
we could do it
Okay,
with the
okay.
with not the decimal point there, but I'm not going to give you one that hard on the test. So in that case, you would actually have to round to the tens place instead, because that 2 then would be the last significant digit at the tens place. So
Okay.
don't worry about that. Just as long as you know the way the book describes it with the same number of decimal places as whichever one has the least number of decimal places, that's the rule that'll get you by for addition and subtraction. Okay.
What about, sir? Sorry, I have a question. Yeah, sorry. I put 1043, then decimal. That's it. I didn't put anything.
Same thing. Note that whether I put the decimal point here or not, all 4 of those places are significant figures. So it doesn't change the meaning of this if I say it this way or this way. Now, Alex will tell you something different, but they're wrong. All right. Alex is dumb in this case. So in this case, as long as I know that both of these are measurements, I can report that with or without a decimal place, and it still has exactly the same number of significant figures. Note that that's not always true. So these 2 numbers do not mean the same thing with and without the decimal point. And the reason why is because with the decimal point, we know that zeros after non-zeros are significant in numbers that have a decimal point. So this thing has 4 significant figures in it. This without the decimal point only has 3 significant figures in it.
Yes.
So there is a difference with and without the decimal point here. There isn't here at all. Okay. So if you wrote it with the decimal point or without, in this case, that's a correct answer.
All right. Thank you.
Yep. And let's see what I do when I put this next one into my calculator, 7.66. I use the second function EE. So that's shorthand for times 10 to the So 7.66 EE 15 is 7.66 times 10 to the 15th. And then I'm going to multiply that by 46.885 and divide that by 63. And my calculator spits back 5.700620635 times 10 to the 15th. Okay, so how do we round this with respect to significant figures if all of those things are measurements in there? So 7.66 times 10 to the 15th has how many sig figs in it?
3.
3, because in scientific notation, all of the digits before the times 10 to the power are significant figures. All right, what about 46.885?
5.
5 sig figs. What about 63?
2.
2 sig figs. So
Okay.
those are the 3 numbers that we're using to do our calculation. The rule when we multiply and divide is we have to round to the same number of significant figures as whichever one of our measurements has the least number of sig figs. So 63 is it for us. It has 2 sig figs. So we've got to round our entire answer to 2 sig figs. So 5.7 times 10 to the 15th will be our answer with the correct number of significant figures.
That was a really good guess I did then.
Yes. Okay. Yeah. Same. I was like, I literally guessed it. Was like, yes.
But it's not a guess. I don't want you to guess. I want you to know. Like for each one of these questions with significant figures,
Yeah.
know the rules, apply them, and then you don't have to guess whether you got the right answer or not. You'll know you got it. You can be just as sure as I am when I'm telling you what the right answer is that you got it right. You just have to know how to apply those 2 rules. That's it.
I was totally sure.
Good. I like that.
And so was Catherine.
Good. I like that.
I don't know why I explained it the wrong way, but I got the first one right, and I was really close with the second one.
So let's skip the word problem and do the electron configuration because it's a lot faster and word problems are always a lot more fun. So let's save the funnest one for last. All right.
Great, I didn't get to it.
I have a
That's okay.
real quick question.
I might have a real
Yeah.
quick answer.
It's real quick. You know how oxygen is oxide and like sulfur is sulfide? What's
Yep.
hydrogen?
Hydride.
Hydride.
Are you talking about
Hydride.
in the practice test where you had
HYDRIDE.
No, I'm just saying I totally messed that one up. I answered potassium hydroxide and I knew it was wrong. So I'm like,
So
That's not
that's a
even
common mistake. Remember, so hydrogen is a non-metal. It's the only non-metal that's to the left of the stair step. It's kind of a weirdo being over here. But
yeah.
it's a non-metal. So we name it the same way as any other non-metal in an ionic compound. So hydrogen is the full non-metal name. We chop off the end of it and replace it with "ide."
Okay.
So we can't say hydroxide because hydrogen is not hydroxygen.
Yeah. Well, that was the only thing coming to my brain and it refused
right.
to change. So I'm like,
Hydroxide is a polyatomic ion also. So potassium hydroxide would have this formula instead, KOH, because hydroxide is OH minus and potassium is +1.
okay. All right. There,
All right,
Jennifer, I got that one right now.
Good talk. So let's talk about technetium, element number 43, all right? So remember that we can use the periodic table as our cheat sheet when we do electron configurations. Anytime we begin a new row, we begin to fill a new shell of electrons. Whenever we're crossing a block of 2, we're filling an S subshell. Whenever we cross a block of 6, we're filling a P subshell. Whenever we cross a block of 10, we're filling in a D subshell. All right.
I just saw the no shortcuts part.
No shortcuts. So we cross the first row. We're filling in the first shell of electrons, which only has an S subshell, and there are 2 electrons in it. We begin the second row, so we're beginning to fill the second shell of electrons. We're crossing a block of 2. So we're putting 2 electrons into an S subshell. Then we're crossing a block of 6. Those 6 electrons are going into a P subshell. Anytime we cross a block of 6, we're filling in a P subshell of electrons. We get to the third row. So we're filling in 3 S2 and 3 P6 as we cross that block of 2 and that block of 6. We get to our fourth row. We're beginning to fill our fourth shell of electrons with that block of 2, the S subshell. Then we get to a block of 10. Remember that D subshells always run one shell behind where the S and P subshells run. We do that because the first shell that has a D subshell in it is the third shell, not the fourth shell. So after 3D10, we get to 4P6. And then in the fifth row, we've got to cross that block of 2 and then halfway through the block of 10. So we have 5s2, 4d5. That's the full electron configuration for technetium.
4d5? Oh, I went to the wrong block.
Because 1, 2, 3, 4, 5 across the across the D block there, that's how many elements we are across the D block. 1, 2, 3, 4, 5. And remember, we begun filling the fifth shell with those 5s2 electrons. The D subshell always runs one shell behind that. So we go 5s2 and then 4d5. All right, good practice. So let's think about this word problem now. If 727 trains are racing at top train speed for 760 seconds, what is the total distance that all of those trains together will cover? Now, if it's me, I'm going to solve for the distance in miles because miles is already a distance unit that's in the problem someplace. All right. So how would we do this? How do we know how far one of the trains is covering? Because if we know how far one of the trains is covering, we can just multiply that by 727 to get the total distance for all the trains. So how can we figure out how far one of those trains is going in that 760 seconds?
Isn't it 160? 160 miles per hour is the conversion factor.
It is. That is a conversion factor. So that allows us to convert a time that the train is traveling into a distance that the train travels. Or if we had a distance the train traveled, we could convert that into an amount of time it took for the train to travel that distance. So that conversion factor is very much like density, where we can convert back and forth between the mass of a sample and its volume. All right. So that's the conversion factor that we know for a train between its distance that it travels and its time that it takes to travel that far. So we should be able to take the time that we have, 760 seconds, and use that conversion factor to turn it into a distance. What's the problem with that, though? What's the problem with using our time and our conversion factor together?
One's once per hour and then one's in seconds.
Yes, that's absolutely right. So how can we get around that issue? Now, Anna has a very interesting way of thinking about these problems. We're talking about it today. Her issue or her way of thinking about this might be to take these hours in the denominator of the conversion factor and convert the conversion factor into miles per second instead. If you want to do that, that will work great. All right. So we could convert those hours in the denominator here into seconds, or another way that we could do this is by taking our number of seconds that the train travels and converting that into a number of hours instead. In any case, we just have to make sure that whatever unit we have in the conversion factor matches up with what we have in our information. So we have to get those units to cancel somehow. So I'm going to do that by taking my 760 seconds and converting that into a number of hours. How am I going to do that? Do you know how many seconds there are in an hour? If you don't, how would you do it if you didn't know how many seconds there were in an hour?
Divide by 60 twice.
Well, that's very convenient, but it doesn't tell us anything about how the units are going to cancel. So why would we divide by 60 twice? Let's think about the units. So if you're dividing by 60, you might be talking about converting seconds into minutes and then minutes into hours. Olivia, is that
Yeah.
fair? All right, so if we do that, our units are going to have to look like this. So we would divide by 60 because there are 60 seconds in every 1 minute, right? And then we could convert from minutes to hours because in every 1 hour, there are 60 minutes. So after those two conversions, now the time that the train is traveling is now in units of hours instead of in units of seconds. So if I canceled all these units out, the only units left now are hours. That's the amount of time that this train is traveling in units of hours. So can't I multiply by my speed now in miles per hour? So my hours will cancel and my new unit will be miles, right? So what I've just solved for here is the distance that one train will cover in that 760 seconds. So if there are 727 of those trains, I would have to multiply that distance by 727 to get the total distance that all the trains have traveled. So my calculator is giving me 24,556 miles. Yeah? Are you guys getting the same thing? Hello, darkness, my old friend.
I hear you. I'm just dyslexic.
I've come to
can't
talk with you
Do it as fast as
again.
you.
It's totally fine. I just want to check to see if you guys are getting the same thing I am from the calculation.
I'm just not used to this calculator, so it takes me a while to use it.
Now I have it stuck in my head. Thank you, Dr. Musk.
You're welcome. Just listen to it after class. So as you finish up your calculation and realize that you're getting the same answer as me from your calculator, look at the measurements in the problem. 727 is a counting number. That is not a measurement with uncertainty in it. There are exactly 727 trains, not 727 plus or minus one, all right? 160 miles an hour, that's a measurement. 760 seconds is also a measurement. Each of those measurements have only two significant figures in them. So if we're using them to do a calculation where we're multiplying and dividing, we are going to have to round the answer from our calculation to only 2 significant figures. So that's why I rounded my 24,556 to 25,000 without a decimal point.
Ow.
So I'm trying to hit on the kinds of questions that people tend to miss on the exams. One of them is anything to do with using conversion factors. All right, so this is a question that has conversion factors in it. It's conversion factors that are pretty easy to handle, but if you don't know how to get your units to cancel out, then you're going to have a hard time with these kinds of questions. So it's good to practice. A copy of this worksheet is already available in the place where our recitations are listed under today's date. So I'll add the video to that link later, but for right now, the worksheet is already there, and I already sent a link to it in the announcement before class today also. Okay, so we have gotten done with our review time today. Catherine, you had the question about potassium hydride. Is there anything else that people want to ask about, like that you need help with before we move on to beginning our practice with chapter 4 stuff? Remember, chapter 4 is not on exam 1, but we got to cover it sometime soon. So we're going to start practicing with that today.
I have a question about Alex.
Okay.
Or is it some fun?
Oh, you already are sharing screen, so okay.
Go ahead. You can share your screen.
This one. I don't know. Let's go this one and then. Okay, so this one and then. Okay, so good news is I took snippets of it, and this is not it. This is it. Okay, so. This is, it's like write the empirical formula for at least 4 ionic compounds that can be formed from the following ions. This is what I wrote.
Okay, give me just a second. Give me just a second. I'm writing. All right, we have Fe2 plus, BrO3 minus. That's a polyatomic ion you guys don't have to know, but you don't have to know what it's named in order to be able to write formulas with it. And then MnO4 minus, that's another polyatomic ion you guys don't have to know about. Okay, I got it, Jules. So
okay, wait, and then here's what it said it wanted.
Yep.
I'm confused. What is
all right,
this?
look, got it, totally got it. Those are the formulas for all the ionic compounds that we could make by putting those ions together to make ionic compounds. So let me share my screen again. Okay. So I have those 4 ions listed. This has been a topic also that a couple of people have asked about, so it's good that we're doing an example. So this is a metal ion, iron with a +2 charge. This is also a metal ion, iron with a +3 charge. These are both polyatomic ions, so they have negative charges. They would take the place of a non-metal in an ionic compound. If we had to write the formulas for any ionic compounds we could make with these, we could imagine putting these 2 together to make an ionic compound, or putting those 2 together to make an ionic compound, or these 2 together to make an ionic compound, or these 2 to make an ionic compound. So that's 4 different formulas that we have to write based on charge balancing these ions. So if iron is a +2 and bromate is a -1, then we would need 2 of those bromates for every 1 iron in the compound. Note that in the formula, Jules, we don't put that Roman numeral. All right, the Roman numeral is, if we were naming this compound, it would be called iron 2 bromate.
So wait, so when when you have more than one of the pieces of the thing, you don't put the number in front, you put it as a subscript.
When we have more than one polyatomic ion, we write how many of them we have as a subscript outside the parentheses.
Oh, okay.
So we'll do one more example like that when we're done. All right. So really quick, iron 2+ and permanganate with a -1 charge. Putting those two together, we would need 2 permanganates for every 1 iron 2+ in order to charge balance. See, these are easy because they're both -1s. Let's try one more of these where I'm going to give you a couple of different charges. All right. So let's say that we had SN4+ and carbonate and magnesium 2+ and nitride N3-. So if we think about all of the different ionic compounds we could make, we could put those two together or those two together to make an ionic compound. We could put those two together or those two together to make an ionic compound. So we have to charge balance each one of them. So tin is a +4 and carbonate is a -2. So we would need 2 carbonates for every tin in that compound. Note that I'm not naming this right now. So if I was naming this, that is when I would have to use the name tin 4 carbonate. And the reason why is because tin can have different charges as an ion. All right. Now, when I put magnesium and carbonate together, MgCO3, I don't have to have the parentheses because I only have 1 carbonate. If I were naming this, I would just name it magnesium carbonate. And I would name it that because magnesium is only ever a +2. It's a main group metal that can only have 1 charge. Does that make sense so far? I'll let you guys finish the other couple of them if you want to, and if not, that's totally fine. But that's how you get through that topic, is by writing the correct formula for each of the 4 possible compounds you could make by putting those ions together.
Yeah, no, I wasn't sure how to write it. Okay, that makes more sense now.
It's a formula, not a name. So those Roman numerals are only in the name when we're naming a metal ion that can have more than 1 kind of charge. All right. So for the transition metals, and I'll tell you that on the exam, like if I gave you a compound to name, something like this,
Okay, so we've got.
if I gave you a problem like this and said, name this compound, I would tell you that the metal rhenium can have different charges.
You
That
mean
is your.
rhodium?
Oh yeah, rhodium. Sorry, rhenium. I do mean rhodium. Rhenium's RE.
Rhodium, sulfur, oxygen. Man, you got a transition metal, a sulfur. Man, you threw in 2 extra wonky ones.
It's not extra wonky at all. This is something that should be very familiar to you at this point. If you made your flashcards, like Jennifer and I have been telling you to do for quite a while, This is one of the polyatomic ions that you should have memorized, both its formula and its charge.
Oh, I just got to that today. Hold on.
Like these.
Sulfate.
Sulfate, which has a -2 charge. So if each one of those sulfates is a -2 and we have 3 of them, sulfate is a total of -6 for those 3 sulfates, which means each of the rhodiums has to have what charge in order to charge balance?
+3.
Posies.
+3. So the correct name for this would be rhodium 3 sulfate. That is when we use those Roman numerals in parentheses, is when we're describing what the charge of a metal in an ionic compound is as part of its name. We only have to do that when that metal can have more than one different charge as an ion. All right. Okay, so now that we've practiced naming ionic compounds, the thing that I want to practice a little bit from chapter 4 today is how we name covalent compounds. So covalent compounds are what we get when we put nonmetals with other nonmetals. For example, CO or CO2 or H2O, those are all covalent compounds that you guys have heard of before. C12H22O11, whether you know it or not, you've heard of that. Something like this. Okay, so the difference when we have a covalent compound is that there's no charge to balance out here anymore. All right, we're not talking about things where the metal ion has a positive charge and the non-metal a negative charge, because these are all non-metals. So when we have a covalent compound, the way that we name it, at least when we're talking about something like a binary covalent compound with just 2 different elements in it, we're not going to learn how to name something like this in here. It's a little too complicated. All right. I was just giving this as an example of a covalent compound.
It's sucrose, isn't it?
It is sucrose. That's right. Table sugar.
Yeah, we're learning chemical compounds in nutritional science.
So if this formula represents sucrose, but it could also represent any one of a number of other disaccharides.
Yeah.
It's not enough information to just have this formula and say that's sucrose, even though sucrose does have this chemical formula.
Yeah, that's
Okay.
the basic one that they give us.
Yep. Yep.
For that, and glucose is a little different. But anyway, yeah, sorry. Other class.
That's great. I'm glad that you knew the name. So we're going to focus just on covalent compounds that have only 2 different elements in them. All right, those are called binary covalent compounds. Binary means 2. So binary covalent compounds just have 2 different nonmetals in the formula. All right. Now, the way that we tell how many of each of those is by using prefixes to talk about how many of each of those kinds of elements there are. So in CO, the prefix for 1 is mono. So you might think that we would name this monocarbon monoxide. But it turns out that whenever we have just one of the first kind of element, we can drop that prefix for the first element. So you guys have heard of this name before, carbon monoxide. And you've probably heard of this before as well. What would we call that thing? We'd have to use a
Carbon dioxide.
There you go. So our prefix for 2 is di.
Three is Try.
It is.
TRI. I can't remember 4.
We're getting there. I'm writing them down. You just can't see.
I'm muted. I was gonna say quad.
I was
Thank
wondering why
you.
it was so quiet.
That's some shade.
Ah, that's fair.
Okay, so here are our prefixes. Now, remember that when we're naming ionic compounds, we don't need to use these prefixes for ionic compounds because they have to charge balance. That's how we know how many of each thing there is in an ionic compound. We only use these prefixes when we're naming covalent compounds because these don't have charges the same way anymore, all right? So CO2 would be carbon dioxide. NO2 would be nitrogen dioxide.
So if it was NO3, it would be nitrogen trioxide.
Correct.
Okay. Okay.
What about
okay, I think I'm getting
H2O?
it.
How would we name
Dihydrogen
H2O?
That's
monoxide.
water.
There you go. Dihydrogen monoxide.
Quite
Now
deadly in a lot
note
of
that
things. we eat.
sometimes when the element has the same first letter, or when the element starts with a vowel and the prefix ends with a vowel, sometimes we drop one of the vowels and sometimes we don't. So as long as you're really close, then you're not going to lose points on that. Yes, we could also call this water. Water is the common name for this. This is the systematic name for water as a covalent compound. What about this one? P2O5. What do you think of that?
Diphosphate
Diphosphate
pentaoxide.
pentaoxide.
Diphosphorus. Now
Gross.
remember, we don't cut the end off of the first element that we named. It's the same as with our covalent compounds. We truncate the name of the second element and replace
Oh.
it. So what about 5 oxygens? How would we name that?
Pentaoxide.
Very close.
Pentoxide.
Yep. So in that case, chemists sounded thought as a matter of ear, as a matter of the way it sounded, it sounds less weird to say pentoxide than pentaoxide. So they cut it the one vowel off. And it's not all the time either, which is confusing. So let's look at this one. This is one of my favorite compounds in the world because it's an explosive and I make it in the lab when we actually have in-person labs. How would you name this stuff? There's only one nitrogen, so we just say nitrogen, not mononitrogen. And then,
Triiodide.
yeah,
Triodide?
Triodide.
it's actually triiodide. So as a matter of ear, they thought that triodide sounded weird and triiodide sounded better. All right. It really is just a matter of ear. All right. So yeah, don't worry about it. If you had said triodide on this on an exam, full credit, because that's something that you just get to know how the elements interact with these prefixes after you write like 6 bazillion of them and are old and gray like me. Or at
You're not
least
old and
partially
gray.
old and, oh, I'm gray. I don't know if I'm old yet, but I'm gray.
I
If
forgot what
you line
9
up,
was.
you'll
What
see
was
a you'll see a
what was
drastic
the prefix for
transformation.
9? I forgot.
9,
It's like
Nona.
Nona. Okay.
But in reality, the binary ionic or the binary covalent compounds we're going to name are probably not going to use anything bigger than 6 or 7. All right.
Hey, it doesn't hurt to help to
I
know
know
it,
that.
right?
I know that. Well,
You
there are
say that,
there are
but Alex
prefixes
said
for
something
10
different.
and beyond too. We could have prefixes all the way up to 30 or 40 if you wanted, but we're not going to do that because it's just too much crap to know.
It doesn't hurt to help. It doesn't hurt to know it because Alex is going to come up and tell us,
But
hey,
in
you got to know
in
this.
homework, you can look up the prefix if you don't know it, right? On an exam, you're never going to have to know a prefix bigger than 9 anyplace. I promise.
Not even in Chem 2?
No, Not even in chem, not even in the 160 series.
Wild. Good
Yay.
to know.
So P2O5
I
diphosphorus
used to know these in
pentoxide.
high school.
Let's do one more of these together.
I don't know, because I get it wrong every time, so I'm scared to answer anymore.
Don't be scared. Just try it. So there are two carbons. So what do we put for our carbon?
Dicarbon
Dicarbon
sulfide.
sulfide? No, it's not sulfide. It's
Carbon.
There's not just-
sulfide.
Tetra,
Tetrasulfate.
Tetra. Tetra.
Sulfade, not sulfide.
Sulfide. We're using
IDE.
that prefix
IDE.
IDE. The only time we use eights or ites is when we're talking about polyatomic ions. All right, so sulfate and sulfite mean something very different than sulfide.
I quit.
Don't quit, just practice. You don't have to be comfortable with this yet. It's the first time that you've seen it.
You know why I'm wildly
I'm just trying to get
uncomfortable with
100% on this Saturday, okay?
So this isn't even on the exam for this week at all. This is exam 2 stuff, but we got to start covering it sometime, right? We got to cover chapter 4 and practice with that this week, or else we're going to be way behind. Jennifer, I've heard that one before. Tetra, fish have 4 fins. But do they really have 4 fins? They've got the like dorsal fin, then a
Technically, it's
pair
like
of
3.
caudal fins and anal fins. And
Yeah.
there, yeah,
depends.
and
Depending on the
honestly,
fish.
yeah, depending on what kind of fish, they can have more, like a lot more.
They can
or
have a lot
less
more.
fins. Weird, huh?
Yeah, no, marine biology, it's a lot.
It's amazing.
Good luck, Sarah.
I'm finishing it, so I've already done some of it. So I know a little already.
Do tetras have exactly 4
I think
fins?
just tetras have 4 fins.
Which all right, now I've got to go look at a picture of a tetra so I can see how many fins they have. I totally believe you, but I just never thought to make.
I
the
don't
connection.
believe you.
No, I believe it.
No,
but
I do.
I never thought to count my fish. I never think to count my fish's fins. So
I see 5, but I think if you just sliced it in half, it would be 4.
That's a little macabre.
Yes.
We don't want to
is
slice
this-
a tetra in half. Poor thing.
I mean, we eat them.
I was just trying to make it so the
Uh,
numbers add up.
Tetras? You eat tetras?
you eat
It's like
tetra
a-
fish? They're like the size of a
I-
nickel.
Depends how hungry I am, people.
Yeah, I suppose that's true.
They're
but I've
seriously
never.
okay. The size of a quarter. They're the size of a quarter.
Swallow
You
them
eat
whole.
fish
They
the
have
size of a
protein
quarter.
somewhere. You're trapped on an island. I'd
We're
eat it.
devolving. Let's evolve instead. All right.
Yes.
We have a few minutes left. So the naming convention for covalent compounds is as far as I wanted to get in practicing in chapter 4 today. So we have a little time left. Let's try and do another conversion factor problem before we're done. All right.
Yes.
Because I guarantee you that's something that more people are going to miss on exam 1 than most of the other questions. All right. So I'm going to make one up.
That they have 6.
Well, that just totally defeats the mnemonic device, though. So if you're trying to remember the
Like
prefix
methane.
tetra, then they have to have 4 fins. So you could, if there was a species of fish called a hexa, you could say hexas have 6 fins.
Okay, so it's gonna have 2
I just think
Boring.
hexagon for hexa.
and some methane. Oh, I don't need to. Why am I writing out the full name for dichlorine methane?
And is the exam gonna be multiple choice, or is it gonna kind of be exactly how like the practice exam is, where you want us to
The
kind of write
format
it
will
out?
be very similar to the practice exam. The practice exam had multiple choice questions on it too.
Well, what I'm wondering is like for, to show your work, how,
So what you're going to do is you're going to print a copy of the test and take it just like it was a paper test.
okay,
And then you're going to use your phone to take a picture of each page and turn those pictures into a PDF file to submit.
Wait, what if you have
Okay,
a
I can do
scanner? Can
that.
you just scan it?
You can
Yeah.
scan it and turn it into a PDF also.
don't
Cool.
open a Google
That's what I
file.
want is I want one PDF file with all your exam pages on it.
Oh, one.
And not just, the first and the last page of the lab and not
Yeah.
the middle,
Right.
like some of us.
I gave you a chance to fix it.
I know, I appreciate it.
Microliters of dichloro. What was I looking for? Oh yeah. What the
If you
heck
get
is
a
the
chance to
methane?
fix it, fix it.
Oh, I did.
You
Immediately.
don't have to know what this is. If you're curious,
2 chlorine with some methane.
CH2Cl2 is dichloromethane, but that doesn't matter. It's immaterial. So we know the density and we have a mass, and it's asking how many microliters of that stuff have this mass. So we know that densities are conversion factors that let us convert back and forth between a volume and a mass, right? So how many microliters is it? You're given a mass, try and convert into a volume in microliters. Ooh, I just came up with a good question. It's going in the exam this week.
Why?
Yeah, what is it? Maybe.
I'm not telling,
Why?
because I don't want to let the cat out of the bag. It's going to be so much fun when
No,
you
that's
get
not what I'm
surprised by
asking. I'm not asking why you're not telling us. I'm asking us why you're putting a new question in.
Well, I'm writing a new test.
Are you basing these practices based on what people get wrong on the practice exam?
Yeah,
Okay,
not
okay.
just on the practice exam, on the real exam, because we have
because
years and years of data to support which questions students tend to trip up on.
So I messed up on 22 on the practice exam because I totally. So I thought when you take away 3 electrons, it became a negative, and I went dumb.
Nope, if you take
I
away
went
3
dumb.
electrons, it becomes a
Yeah,
plus
it
3.
becomes positive. I went dumb.
So just don't do that on the test. It's a practice. That's why you took the practice
It
test.
was like 6 a.m. this morning.
Again, I don't know why you were doing that at that time.
I was awake.
Yeah, that doesn't
Why
mean
was
you...
Dr. Musk up at 2:30 in the morning?
Yeah, it happens. Honestly, like for the last week, the hours that I have felt human have been pretty sporadic. So even I got my second dose of the vaccine a week ago today, no, a
Mhm.
week ago yesterday. And yesterday all day I was running a fever and
Mm.
still feeling like crap. So, and I felt okay a couple of days in that span, but it's just like, I'm trying to get work done when I feel good. I felt pretty good all day today.
So during the exam, as long as we have no other tabs open, we can use whatever paper material, like our notes and stuff, right?
You can use whatever paper material you want. You can use your ALEX calculator if you want to, and the ALEX periodic table if you want to. You just can't internet search. And I
Okay.
will reiterate again that I will be able to tell if you internet search. I'm
Well,
not
yeah,
going to say how.
It's a coding in the programming of the test, isn't it?
Somehow, yes. All right.
Yeah, it's very
But
common, especially
I'll-
for like state and college exams.
Yeah, I'll be able to
Graham,
tell.
wait,
I don't want people to internet search, because even if there are only a few questions that let me know that you did it, that means that you could have done it on all the questions And I want the test to be you taking the test, not frickin' Google.
Wait, no, I'm looking at Ms. Lawson's screen and I'm confused. Why did she went with grams if
Actually, I can't see the problem anymore, so I'm not sure I'm doing it
Neither
right.
can I.
if dichloromethane has
I
a
got it.
density
Here, we're back.
of
I just
Oh.
wanted to see you guys' faces because we were chatting. I know I can see.
Well, you
on the
can
grid.
set it to whoever's talking is whose face you see too.
I know, but I don't like that because I like to see people's reactions too.
No, my face has no filter. You always know my reaction.
I'm
So-
gonna need space here.
I'm going to try and solve this a completely different way than I normally would. And the reason why is because Anna was asking about density questions today, and she came at a problem like this in a very different way than I did. And guess what? It's every bit as good as the way that I solved this problem. All right. So if I were solving this problem, I would set up my units very much like Jennifer's screen, where I'm going to convert my mass into units of kilograms because that's what's in the density. And then after that, I will have my number of liters after I use density as a conversion factor, and then have to convert those liters into microliters. What if instead of converting my mass into kilograms and then at the end my liters into microliters, what if I changed the units in the density to match the units that I want in the problem? That's perfectly valid as well. So what is the density in units of milligrams per microliter? Can we solve for our density in those units? Because if we could directly convert our number of milligrams into a number of microliters. So if we start out with our density in units of kilograms per liters, can we convert those kilograms into milligrams? Sure we can. We know that in every 1 kilogram, there are 1,000 grams. We know that in every 1 gram, there are 1,000 milligrams. Now, the units that are left over in this density are milligrams per liter. So our kilograms cancel, our grams cancel, and we're left with milligrams per liter. Can we convert those liters in the denominator into microliters? Sure we can. We're canceling out liters in the denominator, so that conversion factor will have to look like this, with liters in the numerator and microliters in the denominator. And we know that in every 1 liter, there are how many microliters?
Bajillion.
I only heard half of that. I'm sorry.
I said a bajillion. It was, I don't, my brain's fried.
How about a million?
Oh,
10 to the 6th microliters in every 1 liter. And interestingly enough, when we do this calculation, 1.38 times 10 to the 3rd times 10 to the 3rd divided by 10 to the 6th gives us 1.38. But the difference is now our density is in the right units. It's in units of milligrams per microliters. So how do we take our mass in milligrams and convert that into a volume in microliters? We know that the density tells us that this sample weighs 1.38 milligrams per every 1 microliter of sample. And because our number of milligrams only had 3 sig figs in it, and our density also had 3 sig figs, I rounded my answer in microliters to 3 significant figures. So Anna solved a problem like this way, and it's very different from the way that I've set these problems up in front of class. Does that mean that her way is worse or better? No, it's just different. She decided to focus on changing the units in the density to the same units that we need in the problem. That's a great strategy. If you like this way of doing density problems, convert the density into a new set of units and then use it, do it. That's awesome. All right. In the end, the underlying principle, no matter whether we do it the Anna method or the Dr. Musk method, it's the same method. We have to worry about making sure that our units cancel out to give us the units that we're asked for in the problem. So I just wanted to give Anna tons of props because her way of doing this is every bit as valid and awesome as my way of doing it.
Because in the end, it doesn't even matter.
Yeah, it doesn't. If the units cancel out the same way, then it really doesn't matter.
Student of the Month award goes to Anna.
I just try and give props to people when I can. And I thought that that was a perfectly fun and valid way to solve this problem. So I wanted to do an example and solve it that way because it's the same. All right. In the end, we handled the unit conversions a little differently. So I would have focused on converting these milligrams into kilograms first and then using the density conversion factor. Instead, why can't we just convert the density into the right units and then do our conversion with that new density? There's nothing wrong with that. It's perfectly valid. I think that's pretty awesome, personally. Any other questions before our time together is up? I mean, we're past an hour, but I mean, we can do more practice if you guys want to practice anything else. Hello, darkness, my old friend.
I've come to talk with you again.
Dun, 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 dun.
Because of visions of me.
Everybody still knows Simon and Garfunkel, but nobody knows Saved by the Bell anymore. I don't know.
I know Saved by the Bell. How young do
Nobody
you
knows
think
Saved by
I
the
am?
Bell.
That name sounds familiar.
Wait,
I-
like
I
the
don't
TV
remember-
show?
I don't-
Like the TV show, yes.
What do you mean nobody knows the TV? I don't understand.
Students that are first year full-time freshmen in college, most of them may have heard of Saved by the Bell, but they probably never watched an episode of it, which is kind of it. I mean,
There's something wrong with that.
I hate to tell you, Dr. Musk, but I am old.
that's okay.
I grew up with that show.
I just
And
know
Jennifer
it's a
says
TV
she has no
show.
idea what Saved by the Bell is.
No!
Jennifer.
So Jennifer, it would have been maybe a little after the time when you were watching like teenage kinds of shows. But it's a teen comedy.
Shame.
The
It's
best
always,
Shame.
reason-
it's always associated with like the Degrassi, but
Yeah, but Degrassi was a lot more edgy and
Yeah.
like there were
What's Degrassi?
Don't worry
Degrassi
about
was
it.
a Canadian TV teen
One-
show.
One that
Don't
I
worry about it.
remember where I fell in love with Ryan Reynolds was called 15. And
Never
that's
heard of
where I
it.
first saw Ryan Reynolds. And I was like, oh my gosh, I'm so in love.
I still love Ryan Reynolds, so.
Okay, so be looking on Tuesday and Wednesday. We will have another set of Ryan Reynolds. You don't know who Ryan Reynolds is, Jennifer?
Jennifer!
jeez.
Really?
Oh jeez.
I have no
I
idea.
actually feel bad for you
Deadpool?
because he's a very pretty man.
He is a very
Deadpool.
pretty man.
You
So-
don't know Deadpool.
Let's
Wait,
take a look.
I don't
You
watch.
watch TV,
That's
Jennifer?
all right.
I've never
It's a-
watched Deadpool.
Because some
Okay.
people don't watch TV. Like, so
Yeah,
they-
some
need-
people don't watch it, yeah.
I need one
Yeah,
more
moving
good minute.
on.
One more good minute. All right, one more good minute. So on Tuesday and Wednesday, be looking for announcements or in the recitation
Do you
module
mean Wednesday, Thursday?
on Wednesday and Thursday. Be looking for another set of short worksheets for each day. All right, we'll have a worksheet for tomorrow and another worksheet for Thursday. It'll just be a couple of practice problems that will help us review things that students normally screw up on exam 1. All right. And then tomorrow for our chapter 4, we are going to be learning to draw good Lewis structures. So try to take a look at the chapter 4 topical video on drawing good Lewis structures before you come tomorrow night. All right. If not, it's 3 steps. It's pretty easy, and we'll kind of learn by practicing if you don't have time to get to it.
Okay.
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 I'm going to hand the meeting over.
I gotta go make food for the teenager before he starts eating his own bed sheets.
All right, everybody. I'll see you tomorrow night.
Bye. Have a good night. Thank you,
Bye.
Dr. Mack.
Night.
Bye.
See you.